All right, so as we talked about last week when we started chapter 7, this is our algebra chapter, and so we're going to be focusing on using equations like formulas, plugging things in, evaluating. That's what you did in 7.1. And then we're going to be focusing on solving algebraic equations as well. And a big part of solving algebraic equations is knowing how to correctly simplify expressions. And this largely comes down to something that we call combining like terms. So this is what you're going to be focusing on in section 7.2, not actually solving. There'll be no equal sign in these statements, but just simplifying by combining like terms. So you've got a very good breakdown here of what we mean when we talk about like terms. Basically, when you look at any term, and terms are things that are either being added together or subtracted from each other. All right, that's what we're talking about when we look at terms. Every term is going to have two parts. All right, it has its numerical part. We typically call that the coefficient. And it has its literal part, which is essentially the part that contains a variable or variables, right? X, Y, T, whatever it happens to be. And so the main thing that we have to remember is we can only add or subtract, combine terms that have the same literal parts. All right, so for example, here, if we look at the literal parts, the parts with variables, they are exactly the same. XY squared, XY squared. And so because of that, we can combine them. And when we combine them, we just combine by adding or subtracting the numerical coefficient. All right, so for example, 3xy squared plus 7xy squared. All right, the literal parts are the same, and they will stay just as they are. If we add the coefficients, the 3 and the 7, this becomes 10. And again, the literal parts, the variable parts, stay exactly the same. All right, now, if you compare that to this example right here, you have 3x squared and 2x, right? So you look at those, you look at their literal parts. Yes, they have the same variable, right? They both have x, but their literal parts are not exactly the same, right? X squared is not the same thing as x. And so because of that, we cannot combine those two together, right? That means if we were looking at an expression with 3x squared plus 2x, we could not simplify that at all. They would have to stay as two separate terms. All right, so let's look at a few examples here and talk about what we can combine and what we cannot combine. All right, so in part A, again, what we're going to look for is terms that have the same literal parts. All right, so I've got 4 terms here. Right, again, these are the things that are being added or subtracted. And if I look for terms that have the same literal parts, all right, the first ones I see are the x's. All right, those have the exact same literal terms. So I look at the numerical coefficients, right? I have a 5 minus 2. That's going to give me 3. And remember, the literal part, the variable, stays exactly the same. All right, now the other thing that I can combine here would be the xy terms. Those have the exact same literal parts, right? There's no difference. And so I can combine their coefficients. I've got a 4 minus 3. Always take the sign that comes in front of it. 4 minus 3 is 1, right? And so I'm going to write this as plus 1 x, y. All right, now, you'll notice when you're going through here, you don't have to put a 1 in front of things. And so you would commonly see this written 3x and then just plus xy. I just put the 1 in there so that you could see all we're doing is combining the numerical coefficients. But again, you don't have to put a 1 out there in front. And so when that happens, you can just leave the literal part. All right, so let's look at part B. Again, I'm going to go through and look for terms that have the same, exact same literal parts. So the first one I see here, the first term, has a literal part of AB squared. The only other term in here that has that same literal part, exactly the same, is a negative AB squared. So if I combine their if I combine their numerical parts, the coefficients, I've got 3, and then technically that's like a minus 1. So that would become 2, and their literal parts would stay exactly the same. All right, now, the next literal part I see is an a squared b. So again, I'm looking for things that have the exact same literal part. There's an a squared b here and an a squared b here. So looking at their coefficients, again, remember, if there's nothing in front, it's like there is an implied 1. All right, so I've got a 1 plus 3, right? That's 4. And then technically I've got a minus 1 here, which is going to give me a positive 3a squared b. All right, and notice at that point I can't simplify this anymore because these two terms do not have the same literal part. One is ab squared and the other is a squared b, so I can't do anything more to that. All right, in our next one, the first literal part that I see is x. Now remember, if there's nothing in front of it, there's like an implied 1. All right, so I look for others that have the exact same literal part. There's an x here. There's an x here. Again, I'm going to put a 1 in there just to clarify. And so if I combine their numerical coefficients, I've got 1. Here I've got minus 2. Now be careful with signs. 1 minus 2 is negative 1. And then I've got a minus 1 here. Negative 1 minus negative 1 would be negative 2. And the literal part x would stay the same. All right, the next one I see is a y. I've got a 2y here. I've got technically a negative 1y and a positive 2y. All right, so combining their numerical coefficients, I've got a 2 minus 1 would be 1, plus 2 would be 3, and the literal part stays the same. All right, and then finally, I've got a negative 3z, a positive 5z, and a negative 1z. All right, all those are the exact same literal part. Variables are the same. So if I combine their numerical coefficients, remember, take the sign that comes in front of it. So this is negative 3 plus 5. Watch your signs. Negative 3 plus 5 is positive 2. And then minus 1 is positive 1. So technically, I'm looking at a positive 1z. But remember, when there's a 1 in front of it, you don't have to include it. And so this would more commonly be written as just z, plus z. And at that point, I couldn't simplify anymore because the variables, the literal parts, are not the same. All right, keeping on here. All right, again, look for the exact same literal part. So this is a PQ. All right, so I'm looking for the ones that have the same thing. I've got 17 minus 6, right? 17 minus 6 would be 11. And then this is technically a 1, negative 1 in front of it here. So 11 minus 1 is going to leave me with 10 PQ. All right, and then the next literal part that I see is a PS. All right, so look at all the ones that have that same literal part. I've got negative 9. Again, take the sign that comes in front. Plus 1. That's going to be negative 8. And then I've got minus 6, which is going to give me a negative 14 PS. And again, at that point, completely simplified. Can't combine that any further because I've got a PQ and a PS, and those are not the same literal terms. All right, and then one more here. The first literal part that I see is x squared, right? So looking for all the ones that have the exact same thing, x squared. I've got a 4 minus 1, right? So that's 3, plus 2. That gives me a 5 for the coefficient, and the literal part stays exactly the same. All right, then I see I've got an x term here and an x term here. That's positive 2 plus 1, technically, and so this is going to be a plus 3x. All right, so that's the first thing you want to understand is just what types of terms can you combine. And remember, that just means they have to have the exact same literal part, no change at all, right? No difference at all. And when that happens, I can combine them by adding or subtracting the numerical coefficient and keeping the literal part exactly the same. All right, now, the second thing is what to do when these expressions that you're trying to simplify contain parentheses. All right, so you've got a few basic rules here. The first thing you want to do if you're trying to simplify an algebraic expression is get rid of parentheses. Right? You can't simplify it if parentheses are in there. And so the way we do this, right, is we look at what's in front of the first parentheses. All right, now, if what is in front of the parentheses, the first one, is a positive sign, like what you see here, then you can just drop them. All right, it's not going to make any change at all. However, if the sign that is in front of that first parentheses is negative, then what it will do is change the sign for every term inside the parentheses, right? So notice right here, there was a negative in front of the parentheses, so everything inside parentheses became negative. The x became negative, the 2 and the 2y became negative, and then I was able to drop the parentheses. All right, and then lastly, if there is a multiplier, that just means a number other than 1 out in front, you must multiply each term inside the parentheses by that multiplier. All right, that's commonly referred to as the distributive property. All right, so for example, let's say I have a negative 4, and then in parentheses, I have a 3x plus 2y plus 1. All right, in order to get rid of those parentheses, I have to take this multiplier and multiply it by every term inside parentheses. So the only way I can drop those parentheses, right, is if I take negative 4 times 3x, then I take negative 4 times the 2y, and then I take negative 4 times the 1, right? Everything in parentheses. So this would become negative 12x. It would become negative 8y and negative 4. All right, so we're going to look at a couple together here, and then I'm going to have you walk through and do some practice on your own. All right, but let's look at these first two together. All right, so the first one here, I see parentheses, and if I see parentheses, the first thing I want to do is get rid of those parentheses. So I look at the sign, right? I look at the sign that's out in front. I see the sign in front of the parentheses is negative. So that means in order to drop the parentheses, I have to change the sign on everything inside parentheses. So the first thing I see inside parentheses is an x. If I change the sign, that becomes negative x. The next thing I see inside parentheses is a negative y, right? The sign is what comes in front of it. And so if I change the sign on that, it will become a positive y. Okay, that's what we mean by changing the sign. All right, change the sign to the opposite. Now, in my second expression here, I look at what's in front of the parentheses, and I see this is not just a 1 or negative 1, right? It's not just a minus or a plus. It's actually got a multiplier of negative 5. And when I have a multiplier, I've got to multiply everything inside parentheses by that multiplier. All right, now the 2 is just going to stay out in front, right? It's not a part of the parentheses. So I'm basically just going to kind of carry it through. But then I'm going to have to take -5, multiply it by 3a. That's the first term in parentheses. And then I'm going to have to take -5 and multiply it, watch your sign, by -2b. That's the second term in parentheses. So what's going to happen here is I'm going to have 2 minus, right, this -5 times 3 becomes -15a. And then notice your signs here, right? When I take a -5 times a -2, all right, multiply 2 negatives, they become positive. So this last term will become plus 10b. All right, and that would be my simplified expression. I can't combine anything else, right, because they don't have the same literal parts. 2 has no variable. The -15a has a, the last one has b. All right, those have nothing in common, so I can't do any more combining because what I have now is not like terms. All right, so what I want you to do now is go in and complete the rest of the examples in the notes here. All right, these that say you try, I want you to work through them first. So try these 4, simplify them as much as you can, right? Think about the rules that we've been using, and then I want you to come back and I'll have a quick second video that you can watch where I work you through the solutions to each one of these.